Where would we be without glass? A material that's been refined across centuries of invention and reinvention. In the laboratory, glass is everywhere. Beakers, flasks, bottles, and jars, tubing, stirrers, pipettes, and funnels. All made of glass, and as a result, all very fragile. If glass is bumped or dropped, or if too much pressure is applied to it, it can crack or even shatter, and then we have an accident on our hands. Some glassware-related accidents may not require much more than a Band-Aid, but others can mean a lot of blood and a doctor's needlework. There's also the damaged equipment to consider. It can often be expensive and hard to replace. And in many cases, the potential of contamination from the materials in the container is something we have to worry about as well. So how do we protect ourselves from glassware accidents? Well, we learn about our equipment, inspect it before we use it, and follow proper procedures when we work with it. Each piece of laboratory glassware is made for a specific purpose, and it's important that we use it only for that purpose. Makeshift apparatus is almost always unstable, and it is often an accident waiting to happen. When you have work that involves using glassware, the first thing you need to do is determine whether the pieces you've selected are compatible with the chemicals you're using. This is particularly important for work involving acids and alkalis. Many of these react with glass and can crack or even eat through it. In many procedures, glassware is heated to extreme temperatures. Inferior or flawed pieces can fracture or crack, showering the area with broken glass and hot chemicals. Never use glassware in vacuum operations or gas-producing reactions unless it is specifically designed for these processes. Remember, only certain grades of glassware are capable of standing up to the lab environment, so be careful to use only recommended equipment. Once you've selected the glassware you'll be using, you need to inspect it for flaws. Things like tiny star cracks, chips, and nicks. If you do find any defects, the glass should be pulled from service and discarded or sent to a glass blower for repair. How you handle your glassware is also important. Never carry a flask by its neck or a beaker by its side. The weight of the container or its contents can crack the glass. Always use two hands, one underneath to support the weight. Remember to wear gloves when you're handling, assembling, or washing glassware. It's best to choose cut-resistant gloves that still allow for a high level of dexterity. Insulated gloves should be used for work with hot or extremely cold glass. Many people pick up heated glassware without thinking, and it often ends up hitting the floor. Remember, hot glass stays hot for a long time, so be careful. And while we're talking about temperature, never heat or cool glassware unless it's designed to take the temperature change. Round bottom flasks are recommended for boiling liquids. And never set hot glass on a cold benchtop. The difference in temperature can crack the glass. Scratches in glassware can also be a problem. Even tiny scratches can grow to be cracks later on. So don't use a glass or metal stirring rod to scrape residues off glassware unless the rod has a protective covering. You should also avoid any physical stresses to glassware. Where necessary, stabilize it with clamps and platforms to keep pressure off vulnerable points. Working with ground glass joints is something else that requires extra care. They are finely crafted, so they make a perfect fit. So perfect that sometimes they stick. Never attempt to force a joint free. The glass can shatter from the stress. Instead, lubricate the ends to be joined or use a Teflon sleeve if it's compatible with the chemicals you're using. If some sticking occurs later on, use a heat gun to gently loosen the frozen joint. Now we need to look at glass tubing, specifically cutting and bending it. Not everyone or every type of lab work requires this, but you need to be prepared for that possibility. The first thing to do before cutting any tubing is to double check your gloves and safety glasses. It's important to wear them at all times. Next, position a triangular file where you want to make your cut. With a single light stroke, score one side of the tube. Take hold of the tube with your fingers right up to the score mark. Make sure the score is facing away from your body. Gently pull the ends of the tube towards you, snapping the glass at the mark. Remember to fire polish the ends of the tubing. This removes sharp edges and keeps cracks from forming. In order to bend tubing, heat the glass in a flame until it turns red and is soft. Pull the ends towards you to form the desired angle. Some glassware setups involve pushing a tube or thermometer through a cork or stopper. This should also be approached with caution and common sense. First, make sure that the stopper holes are the correct size for the tubing. Then lubricate the hole at the end of the tube with water or glycerin. Hold the tubing with a towel close to the insertion point and gently twist the tube into the stopper. Positioning your fingers near the end of the tube cuts down on torque stress. This helps to keep the tube from shattering. Remember to wear those all-important gloves. You also need to be careful when you're setting up a stir in your glassware. Make sure that tubing, as well as instruments like electrodes and thermometers, is placed high enough to avoid the stir bar. If the bar makes contact, the whole assembly could shatter. Some glassware may present unusual safety risks. For instance, separatory funnels are often used in processes that involve venting under exceedingly high pressures. This creates a lot of stress. Make sure you've had all the necessary training before working with any type of specialized equipment like this. Vacuum operations are something else that requires special thought when you're using glassware. Vacuums can severely test the quality of any glass you're using. Container walls must be able to withstand the difference between the pressures inside and outside the vessel. Otherwise, the container will implode, sending glass and materials flying. What type of glassware is suitable for vacuum operations? Only round-bottom or thick-walled flat-bottom flasks designed for reduced pressure. Glassware showing repairs should be avoided. In these situations, checking for flaws is also critical. The smallest scratch can cause problems. Flasks, dewars, and desiccators should be covered in tape or mesh to keep broken glass from scattering if it does implode. Another alternative is to use containers coated in PVC. In case of implosion, this coating will contain any glass fragments. Remember, all vacuum apparatus should be placed behind a blast shield. This keeps the containers from being bumped and prevents injury if a container implodes. And personal protective equipment is a necessity. You should wear goggles and gloves for all vacuum operations. A face shield is also recommended. One way to avoid any type of glassware accident is to replace glass with other materials. Consider using metal, plastic, or Teflon connectors and containers whenever possible. Remember though, plastic can sometimes melt from the heat of hot plates and other heat sources. Believe it or not, more glassware accidents happen during cleanup than in any other laboratory activity. So following safe work practices is extremely important. Remember to keep clear of the sides of the sink. Never use a worn-down cleaning brush. The metal holding the bristles can easily scratch and weaken glassware, leading to breaks. Avoid cleaning up with aqua regia, chromic acid, or other caustic agents. These are all extremely corrosive and can also present problems with waste disposal. How you dry the glassware you wash is important too. Small articles can be set out on towels or in lined baskets. Larger containers should be hung on pegs. Storing your glassware properly can prevent a lot of damage. Periodically check that all glass containers are well away from shelf edges. Glass instruments shouldn't be left to roll around in drawers either. Glass bruises. If it bangs into other glass or the sides of the drawers, it becomes more susceptible to cracking. Padding drawers in paper or foam will help prevent these types of problems. When you're working with your glassware, place it well back in the hood or on the bench. This way, nothing will be knocked over by hood sashes or passers-by. It's also important to know how to deal with glassware if an accident occurs. If a piece of glassware begins to fall, let it drop. You could be injured by breaking glass or splashing chemicals if you try to catch it. Use common sense when cleaning up broken glass. Wear leather gloves. Even then, you should never pick up glass fragments with your fingers. Instead, use a dustpan and broom. Dispose of the pieces in a glass-only receptacle. If there's a spilled substance involved in a glassware accident, that material and the broken glass may have to be disposed of as hazardous or biological waste. In some situations, you may be able to use a sharps container. If you're splashed by a potentially hazardous chemical, you need to wash it off immediately. So you should know the locations of the eye wash stations and safety showers in your labs, as well as how to use them. Like many of the things that we use in our labs, glassware has its own set of hazards. By taking the proper precautions, we can work with it safely. Let's review. Know how to handle all of the glassware in your lab. Only use glassware for the specific purpose it was designed for. Make sure that the glassware you select is compatible with the materials and processes you're using. Inspect your glassware for cracks and other damage before you start to work. Know what to do if you have an accident with any glass you use. And be sure to clean and store your glassware properly. If you follow these rules and remember to treat your glassware with respect, you'll end each day with your glassware intact and your fingers Band-Aid free.